Hello, this is now on the lab number 9. In this lab we continue study DAC, digital download converter. So last time we learned how to digitally control the gain of the amplifier. This time we're gonna study how to digitally control the frequency of output of triangle wave and the square wave generator. So we're gonna do the last experiment in this chapter 14. Please go to experiment 14, design of digital programmable square and triangle wave generator oscillator. So basically we're gonna continue do the same circuit that we did before, but in this time we're gonna use 3 op-amps. Before we used 2 op-amps. So we're gonna connect, as we did last time, the DAC to the one op-amp that it goes to the op-amp that works as integrator. Remember, yeah, when we use the capacitor and feedback, it's integrator, and then it goes to the square wave generator. So if we're gonna connect everything like this and see the output after the square wave generator, we should have square wave generator. If we're gonna connect the oscilloscope to just after the integrator, we're gonna see a triangle wave. And by changing the beat pattern like this, like different beat pattern, we can actually change the frequency of output. So your goal is to make this schematics, change the beat patterns, and using this formula calculate the theoretical results and compare with your practical results. Okay, so here it's written measure peak-to-peak amplitude of the output, but also you have to measure the frequency change because different beat patterns should provide different frequencies. Okay, so connect as it's written here. So it's basically the same connection, but this time you also, apart from the DAC here and the two integrator here, you also have to connect one more integrator here. So you're gonna have DAC. One is as it was before, the op-amp after the DAC connects the DAC to the negative and plus current output of 1 and current output of 2. Then the second, after this op-amp, you have to connect the integrator. So you already know how to connect integration. So you connect the integrator, and after integrator, it should go to the square generator. Square generator is going to be here. Okay, so it's connection is the previous, just you have to connect one more op-amp here as integrator. Okay, so once you connect everything, set as usual the supply for 10 volt and see the probe the outputs of the triangle and the square. To see the square output, it should go either after just this square wave generator or just before the FRF. So if we put this oscilloscope probe to FRF, let's say, we should expect to see the square wave. So let's try to change like beat patterns as usual. So here, notice here, this form is a bit different. Before we divided by this, now we're gonna have this divided by 4000. So it means in order to have, let's say, the highest frequency, this value should be 1. So in order to have this 1, this beat pattern should have maximum value 4096, and to have 4096, we should have all ones, right? So let's put all ones. So I already put it all ones / data, and it's highest frequency we can have. So let's try to actually go down. Let's remove one ones and see what's gonna happen with frequency. It increases. Then if I switch it back, so basically if you have 0 here, if you have 0 here, it means your frequency is decreased by 2 times. So and change it to the second one. / data. So let me do it again so you can see the difference. So this is before, Oh, basically we actually increasing the frequency. Let me see. Yes, frequency actually doubles. But if we switch everything to the 0, let me switch everything to 0. And make sure everything goes all the way down. See, it's sometimes stuck in the between. Be careful. Yes, everything is not used to remove it. Flash data. Yes, now it's like lowest frequency, so we even cannot see it. It's just horizontal. No, it's still very down. So let's go one by one. Flash data. Yes, frequency increased. Then second 0, second 1. See, there is a pattern. If you're gonna go everything 0 and switch once, you're gonna have a decrease of frequency. But if you're gonna have everything once and have 0, 0, 0, you're gonna have increase of frequency. So you have to note this, make a table of different patterns and show actually the correlation of different big pattern to the frequency. Okay. So once you do, you also have to actually plot your results. So as it sits here, so you can just read here. So it says you have to plot the x should be your analog equivalent of the bit pattern. Basically, this numbers like 4000, 2000, and the y axis should be the frequency of oscillation. So you have to also plot this. And that's it. And once you're done in your home, you can simulate your DAC using this schematic for your simulation LT Spice. And now let's see the triangle wave. To see the triangle wave, it's easy. Just take this wire from oscilloscope that was connected to the FRF and connect to the input or output of integrator that goes to the input of the square wave. Connect it here, and you should expect the triangle wave. Do the same that we did before for the square. Change the pattern, record different frequencies, and make a plot and make a table.